All right, I guess we'll start. I'm hoping today will go pretty quick for the most part. Objects aren't really that difficult. It's really just trying to understand the concept of how objects in JavaScript are instantiated versus objects in other languages like Java or C++ or any other object-oriented programming language. So before we do that, we're obviously going to do the review like we usually do. Then we'll get into the lesson, and then we'll talk about the assignment. So I have it all ready to go. I'll show you guys what you need to do, and then you have about 4.5 weeks to do it, 4 to 5 weeks to do it. So you've got tons and tons of time, and in full honesty, might take you an afternoon to complete it. I would not wait to the last minute, though. I've had multiple students wait to the last minute, and then they ask me for extensions after a 4-week leeway to get it done, and usually the answer is no. So just give you a heads up. It's also group-based if you want to do it in a group. Obviously, it's only 2 people, though, because it's extremely easy. But you can work with a partner and complete it. I do kind of expect that if you're going to work with a partner that it looks pretty good and has some, pizzazz to it, if that's still a word. Pizzazz. So it just has some flair and looks kind of nice, right? Anyways, we'll talk about that later. Right now, let's talk about last week. So last week we talked about the very confusing callback functions and stuff, right? But we talked about simple functions first. That did not open up the console window. Am I in Chrome? Oh. Helps if we press the correct keys. It's been a super long day. We're changing our office around. So we did a ton of moving this morning, and then we had tons of work this afternoon, and did one of those nasty things where you skip lunch when you shouldn't skip lunch because you need to think. Lunch is responsible for cognition. So I might be a bit dopey today, so I apologize. All right. Talked about concatenation, which is combining. Is this the right lesson? Yeah. Which is combining. Essentially, when you talk about concatenation in programming, usually it's combining something to a string, right? And producing a new string. So it's either combining a variable off to a string or a return value to a string or a number to a string. But either way, you're usually returning back a string. Incidentally, though, when you add 2 numbers together, you're still technically concatenating because the whole definition of concatenating is to merge 2 things together. The easy way to remember that, though, is that it's the plus sign. So whenever you're using the plus sign, you are concatenating these things together, even if they're 2 numbers, technically. You can get into some trouble with concatenation, though, because if you attempt to take a string like 5, like a number 5 or any kind of number, and try to add it to an actual number, it will concatenate the 2 numbers together and not give you the expected result. So that's something you have to be aware of. It's also something to note because it will be on the midterm guaranteed, like absolutely guaranteed. I'll get you to add 2 values together, and then I'll test you against those values to make sure you actually got a number. What should we do with strings if they're numbers? What should we do to a 5, for example? What's our step? If we want to normalize the string 5. So if I have 5, right? Plus 10, how do I make that equal 15 and not 510?
No.
Yeah, who said casting? Yeah, casting, exactly. So we're going to cast it. So we cast it using the number function, right? And then that will equal 15. So we have to normalize it. That's what we're doing. We're normalizing this and turning it into 5 instead of the 5, right? That gets past the concatenation issues. Cool. We talked about string interpolation done with these wonderful things called backticks, right? They're the symbol that goes like this, right? So JavaScript has 3 different quote characters. It has this quote character, has the singular apostrophe quote character, and then it has the backtick. Double quotes and single quotes do exactly the same thing in JavaScript. There's no difference between the 2. There's no efficiency benefits from using either one. Generally, you use double quotes if you're going to be using a lot of apostrophes in your string, then it makes sense to use double quotes. Otherwise, you would have to escape the character. The escape character is done with the backslash, or backslash, that will escape the next character and stop it from being parsed as by the interpreter. The backticks, however, they do some cool things. They allow you to do something called string interpolation, which is basically you can evaluate an expression right inside the string. So you can type out like a whole string, and then you can do this wonderful syntax, and then write whatever you're going to write in there, and it will evaluate this as JavaScript inside the string, which is pretty cool. These are backticks. All right? So we talked about that. Those definitely show up on the test. Then we talked about library functions. There's a whole mess of functions in JavaScript available to you because you have, the window, which gives you access to the browser API. There's the whole DOM structure that's there. There's tons and tons of functions available to you that you should be aware of. The other thing to note, when you define a variable at the global level or you define it using var, it is immediately added as a new property to the window object, which we talked about. And when you define a function at the global level, that function immediately becomes a part of the window object as well. We showed a demonstration, and there is the example in the file as well. We talked about casting, which we just did, string and number casting. We talked about the browser dialog functions, alert, prompt, and confirm. Alert is when you want a one-way message to your user. Prompt is when you're looking for some sort of feedback from your user in the form of a value. And confirm is feedback from the user, but only for yes or no questions, right? So it's only if you need a true or false results, and that's what confirm will return to you, is either true or false. We talked about common object function methods, and the reason why we talked about objects is because in JavaScript, a lot of things, most things, about 98% of things are functions. Today we're going to take, objects. Today we're going to take a look at that a little bit more in depth. But for example, if you want to use the math library, you have to call any of the methods on the math library, starting with the object math. And then to access any of the actual functions, you use the dot operator, which you guys should be used to anyways, because that's syntax in Java as well, right? So, yeah, and C++ is the same way too. We talked about the typical math operators, which you guys should already know. The only one that might be new for some people is the modulo, which basically just gives you, it divides two numbers and then gives you back the return value, like the remaining value. We talked about string functions, like uppercase, or two uppercase, two lowercase, trimming, and then also matching. And then we wrote some custom functions, right? That was fun. We wrote a standard named function. A named function, I mean, it's in the description, right? A named function is a function that has a name, right? So it's easy for you to access. An anonymous function does not have a name, and it's essentially a function value. So you're passing that as a function value, and then you can pass that around your application, and you can either store it in a variable or pass it to other functions or do whatever you want with it because it's just the value, right? That doesn't exist in all languages. It is unique to function programming languages. So calling a custom function, we looked at how to call it. It's pretty easy. You guys have already learned how to call functions. Actually creating a function in JavaScript is slightly different than some languages. It's similar to PHP's way of doing it, and I think Python does it the same way as well. But calling a function is identical in pretty much every single language. You write the symbol name of the function, right? And then in order to execute it, you pass in the two parentheses for the operator. And then that will actually call the function. And if it has a return value, it'll return the value. Otherwise, it'll return back undefined. Incidentally, though, if you don't use these operators, you won't get an error. What will happen is this will actually return back the function definition, which is literally the syntax you wrote for the function, right? We kind of looked at that last week. And that's cool because, like I said, you can pass that around as a value. I don't care if you can't update DivX. That's totally fine. We talked about parameters and arguments. The difference in JavaScript with parameters is that you don't have to data type them. In fact, you can't. So unless you're using like TypeScript or something like that. But in JavaScript, you don't data type them. Also, they're optional. Even though you may have a list of parameters, they are completely optional. If you come down here, if you were to console log all these parameters and you didn't actually pass them as arguments, it will just say undefined, 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 undefined. It won't blow up. It won't throw an error, which can be, I don't know, some people consider that a downfall to JavaScript because you don't always necessarily get errors when you're expecting them. Usually you would get something like a reference error in other languages because you're trying to access something that doesn't exist. But in JavaScript, nope, they're just like, nope, there's just no value there. It's undefined. Undefined is a value, essentially. Arguments, the difference between parameters and arguments. Parameters are placeholders that we use in our function in order to be able to kind of like create little spots where we might have values. We know we're going to have a value there, so we create a little placeholder. Those are called parameters. Arguments are the actual values we're passing to our function, right, when we call it. So there is a difference between parameters and arguments, and I do ask for that on a test. And then callbacks, probably one of the more confusing things that you will deal with in JavaScript. Callbacks are essentially lambdas, right? They're us passing a function into a function and having it call it when it's complete. Or not even necessarily complete. Sometimes callbacks will be called before it's complete. The idea is that we use them generally with JavaScript because of the asynchronicity of JavaScript. So if we're running something that is non-blocking, meaning that it can run in parallel with something else, we want to use callbacks so that we can guarantee that our value is being used at an appropriate time, or whatever we're doing is getting done when we're expecting it to. There are other methods around that, like promises and async and await and stuff, but callbacks are pretty common. The other thing is you're going to be using callbacks quite a bit. Any of the array functions use callbacks. All of the DOM functions use callbacks. So you're going to write tons of them, not necessarily this week, not next week, but the following week. Yes, week 6. You're going to write a whole mess of them. We're going to write tons of them together. And then week 7, you're going to write way more, like double the amount. And then you'll just keep writing callbacks all the way to the end of the semester. So you'll get pretty used to them. It's just, I find it very important to understand that callbacks are just a function definition. It's no different than a value, right? That's all it is. It's no different than passing 5. It just happens to be a function definition that you're passing in, which is kind of cool. Any questions about last week's lesson? No? Cool. Let's get into JavaScript objects then. So I'll close that out. If you want to go to week 4 or module 4, it should be available. That's not module 4, that's quizzes. Let's go to weekly learning. There we go. Week 4, object literals and constructors. And there's a link there that'll take you to the lesson. Just click on the link. And if you have arrived, it will say Introducing Objects. And go ahead and open up that console window because we're going to be using it right off the bat. All right. In fact, actually, the first portion of this lesson is about the console window. And I'll zoom in a little bit so you can see what's going on. Condense this slightly. Zoom this one in. Haven't had a chance yet. I was going to write so that this shows up on the left and an in-lab console window shows up. I just haven't had a chance to do that yet. All right, let's talk about debugging. Usually you do debugging in week 1, right? But I don't know. I don't like to do things in order. Debugging is a crucial thing when you're doing programming, right? Because debugging helps you figure out where you've gone wrong with your code. Now, debugging isn't necessarily going to tell you what you've done wrong with a logic error, but it might help you figure out what's gone wrong with the logic error. It also will give you the ability to stop your application at a point before an error occurs to find out why that error is occurring, okay? Debugging is crucial. Unfortunately, with JavaScript, we don't really have the same kind of functionality that you guys do in, say, like Visual Studio or Visual Studio, where you can actually create like breakpoints inside the IDE. I think you can do that in like NetBeans and stuff like that as well. But with JavaScript, it doesn't really work like that. We have to actually use something in order to create breakpoints. And the thing we're going to use is called a debugger. We're going to use that to create breakpoints. But before we do that, let's talk about what an error message actually looks like in JavaScript. So the JavaScript console, this little thing over here, is absolutely integral to debugging our code. Doesn't matter what browser you're using, they all have some form of the console window. That was done in week 2. There's a table there that tells you how to open that console window, so make sure you can, because it's crucial to helping you with, you know, your errors and stuff like that. So it helps you to become a better JavaScript programmer when you know how to actually destructure the error. Like right now, for example, this thing says code button, eval.js43. That's actually giving us information. Code button is probably just a console message I'm spitting out. Eval is the name of the file where this is occurring. JS is obviously the extension of that file. Does anybody know what 43 is? Exactly, it's the line number. It's the line number that that particular message is being output on. Now, it's not an error. It's not pink. It's not saying warning or error or anything like that, because it isn't an error. It's just an info message. So the JavaScript console actually gives you 4 different types. I'm going to just make this super small on this side so you can see. See here where it says custom levels, right? If you click on that, you get verbose, which will literally spit out all of the information it can possibly spit out about an info, a warning, or an error. It'll just give you everything. There's info. Every time you guys call console.log, that's what happens. It's going out on the info channel. So if you disable info, for example, you won't see your console logs because they won't come out, right? So we usually have info enabled. Warnings are things that the browser may come up with. They can vary. It depends on what it is. Sometimes it's your network is slow. Sometimes it might be a deprecate message. So something's being deprecated. I'm not sure if you guys know what that means. Deprecated usually means that this particular thing you're trying to use is eventually going to be removed from the language entirely and won't be available anymore. That's what deprecation means. So sometimes they'll give you deprecate warnings. And then errors, I'm sure that's self-explanatory. Errors are just errors, whatever errors happen to come out. Now, they're generally pink. That's the color it tends to be when it spits out. A nice big warning so that you can see what's going on. However, I suppress your errors so that I can let you run each one of the IDEs without it just blowing up. So I tend to suppress those, but I do usually write the word error in front of it so that you can see it. Anyways, I tend to, personally, I disable warnings and I disable verbose. I don't usually keep those running. I run info and errors, usually. All right, let's create an error. So errors are generally caused, they can be caused by different things. Some are reference errors. Some can be caused by syntactical errors. So like maybe you're missing a character or something like that, or maybe you missed the semicolon when you needed one, you run on to the next sentence and it's like it doesn't know how to interpret it. There's different ways that errors will actually occur. So if I run this one, for example, and hit execute, it's just going to say console 15. Go ahead and remove, oh, I know why. Hold on. See, I test this code out and there's all my saved stuff. So I'm just going to remove all my saved things. There we go. Now mine will look just like yours. Cool. All right, so if you hit execute, you'll see this wonderful error. Uncaught reference error, whose it is not defined at line 1, character 13, and file m4p1.js. Okay? Now, you don't have a file called m4p1.js. What that actually refers to is M4 is module 4. P1 is practice 1. That's my shorthand code that I've given it. It's so that you can tell inside these little IDEs where the error is. So we know the error is on line 1, and it's around character 13, which is not entirely accurate because it's this thing that's causing it to blow up, which is like character 12 or 9 or something. But anyways, the error message is clear. A reference error is caused when you attempt to access a symbol that is not defined. Okay? That's what tends to cause an error on a reference error. So in this scenario, I haven't defined who's it yet, but now I'm calling length on it, right? I can't do that because who's it hasn't even been initiated yet. It doesn't exist. We haven't done let who's it. We haven't done anything with it. So because it doesn't exist, I'm getting a reference error saying, hey, this thing doesn't exist. You haven't created this thing. There's no address location in memory for it. This thing is gone. Like, it just doesn't exist. What do you want me to do with this stupid thing? It doesn't exist. So it blows up, right? So to correct that, I either A, have to define that variable. So I can do that above. Let who's it, like so. And if I click execute, I'll just get a type error, right? And the reason why I'm getting a type error is because it can't read the property length of undefined. And that's because who's it is now undefined, right? It's there. It's no longer a reference error. The symbol exists. It's definitely in memory. But the problem is it has no value, right? There's nothing inside of it. Undefined arguably is a value, but it doesn't actually contain any information. If you were to look at the memory allocation directly, you would see that it is completely empty. There's nothing been assigned to it. So if I want to fix that, then I got to give it some sort of value, preferably with an equal sign. I'm just going to say, suck it up. There we go. Execute. Cool. Now it works, right? Because now we're meeting all those different pieces that we needed to meet. We've solved the reference error, and we've solved the missing property error, right? So there's a little message below here that says, uncaught reference error tells you the category of the error. I'm going to roll back. You guys can leave your consoles the way you are. You don't need to necessarily edit your IDE piece. I'm just going to roll this back a bit. I'm not sure if you know this, but you can actually hit Command-Z in these little IDE windows. I made it so you can. You're welcome. I'm going to click execute. All right, uncaught reference error. So the first piece that you're looking at is the category of your error, right? So you can actually go look up the category and see what that actually entails under MDN. It's the category of what is wrong with your script, okay? The next piece is the error message itself, okay? So it's the first part is the category. The second part is the actual error message. What is wrong? What is happening? What is this thing that is going on? And that's where we get the who's it is not defined. The next piece is your line number, right? It tells you at what line number this is occurring at, what character it's occurring at, which is not always accurate because there's a lot of things that can define a character, like spaces, tab characters, new line characters, tons of different things can create a character. And then the next piece is the actual file where this thing is occurring at, right? Pretty easy, not too difficult. So I will expect you that when you guys hand in your labs, that you've opened up your console and that you've tried to solve the errors in your console. Oops. I get tons of them. Like I get the last lab that I marked, lab 2. It's all done, by the way. Lab 1 and 2 are marked entirely. But I mean, some of them are like 25 errors down the page that I now have to solve so I can at least figure out where your problems are inside your script. But yeah, so I appreciate it when you open up the console and attempt to solve your own errors first, especially if it's just silly syntax errors, right? Definitely open up the console because you can at least resolve the silly syntax errors, like you missed an equal sign or you missed a semicolon or something like that. All right, cool. Now, it is important to note that this is a bit fabricated by me, but it is basically, they do basically look like this when you create an error. Like if I just, here, maybe I can generate one. Bam, cool. Yeah, so you can see that it's slightly different. It's not exactly the same. And browsers handle errors differently. That's important to understand too. So this is Chrome. And this is how Chrome is dealing with the browser error. However, Safari might just demonstrate it differently, and Firefox will just demonstrate it differently. But the important thing to understand is category, error, and where the hell it's going wrong. That's basically what you're looking for. Cool. So one really interesting tool that we have available to us is called the debugger, and basically its purpose is to allow us to put a breakpoint in our code. So if we're running our code and we keep getting this error and it's just erroring, and we don't know why, what we can do is we can put a debugger in before the error and then evaluate what's getting sent to that next chunk of logic and define whether or not that thing is what's causing the error to happen. Debuggers are fantastic, and it's actually pretty easy to implement. Now, in some browsers, in some IDEs, they give you the ability to just like click the line number and it creates a little breakpoint. Unfortunately, with JavaScript, unless you're like, maybe WebStorm might do that, but most browsers won't, or most IDEs won't do that. We have this word available to us called debugger. And what it basically does, it pauses the application, right? It just stops it and says, but it pauses it in its current state, right? So it's interpreting. Okay, I've evaluated value X, I've evaluated value Y, and pause. And then now you can take a look at what X is and what Y is. And if you call the debugger inside a function or inside a loop, it will pause that function and allow you to evaluate what is being defined inside that function. Or it will pause the loop and allow you to evaluate what's in the loop, right? So it's very, very handy. I use it every day, literally every single day. So this one says, this practice that we're going to actually test, I want to see what the value of sum is. And if I just execute this, I can't see what the value of sum is over here because I don't have access to it, right? Because it's contained currently in that IDE, which is its own little environment window. So if I want to be able to see what the value of sum is, what I can do is I can add a debugger, like so. It's just the word debugger, that's it. You can add a semicolon to the end of it if you want. I don't generally, but because I mean it halts right there, so. Click execute, and you'll notice that if you're in Chrome, it will flip to another tab in your developer tools. This will go dark or it may not. Sometimes it doesn't. Sometimes it stays bright white and it doesn't actually have this overlay. Did anybody's not get the overlay? Just out of curiosity? Okay, that's good actually, because when it doesn't do this, it's a bit confusing. This is your source code. So it actually stops at the source code. And if you look, it's basically showing us all the different pieces of our source code. Now this looks a little confusing because I'm doing some crazy magic in the background that you can't see. So this doesn't necessarily look exactly like our source code, but if you look, minus this word environment, you can basically see the same source, right? We can see here's our step one, add a debugger. We can see the word sum, right? We know sum is currently 0. This is currently iterating and adding a value to sum, though we're not entirely clear on what that value would be. But the cool thing is we actually have access to see what sum is a value of. If you flip back over to your console tab, just click on your console tab and that will flip back over to your console tab. Now this is entirely in Chrome. If you're not using Chrome, you kind of have to figure out what you're doing there. What we can do is we can now take a look at what sum is. Now, like I said, these little IDE windows that I've created for you, they're in like a little self-contained environment. You can't access any of the variables or anything defined on them outside of that environment. They're just inaccessible. You're not scoped in order to access those. You need the debugger in order to see what's being defined inside that environment, just as if you were encased in a function, right? So what I can do is I can type sum right here, hit enter, and I can see that the value of sum is 1,538. Now, in order to move on with my debugger and get past that and resume, I can just click the little play button, and that will resume along, right? And you can see I have an error. This is me telling you the expected syntax is let value equal 1538. This is me giving you an error, right? And to resolve, all we need to do is change line 10 to say equal 1538. Click execute. It's going to bring up the debugger again. That's fine. Just click play. Go to your console, and you should see a pass message on your debugger. Handy tool. Only thing more handy than that is try catches, right? And try catches are easy to do. I believe try catch is exactly the same as it is in Java, as it is in this language. The syntax is the same. That being said, try catch isn't necessarily going to help you, because what does try catch do? Does anybody know?
It tries to catch a error and then throws a.
Well, it doesn't try to catch the error.
Well, like you know what the error might be, and then like it throws it.
Right. So it tries a block of code, right? And if that code produces an error, it catches the error. But in the result of catching it, it suppresses any output of that error entirely. That isn't always necessarily good, right? You don't want to just blanket catch every single error, because then how are you supposed to debug your code? So try catch needs to be used in a proper fashion. When you're doing try catches, you have to catch a specific error. That's the way computer architecture should work. You should be catching a specific error that you know may happen that you want to suppress and possibly log. You shouldn't be blanket catching every single error, right? Because that just makes a poor experience for you. It also means it results in being poor programmed, right? Because you're just letting all these errors occur and they're never actually being resolved, right? Or fixed. So, but these two tools that I've taught you today, the how to read the error line and how to use the debugger, should help you be able to debug your code going forward, okay? Cool. Any questions about any of that? No? Pretty clear, right? All right, cool. This says object recap. And the only reason why it says object recap is because you have used objects before, right? You've created objects. This is going to look butchered because you guys use Java and I don't know Java. Sorry. So I'm now at the point where I know 8 languages and I'm not going to learn Java. I want the thing to die. It should just die. It's so old.
Amen.
So class, right? Person, right? So there's class person that creates a new class, right? This is pseudocode. Apply it to whatever language you're working in. I want to create an attribute, right? So I might have a variable in here. We'll just call it name, right? And why don't we actually do this like we're writing C++?
We have the public.
Oh, yeah. You want me to write public?
Well, I mean, people might.
Oh, what am I writing? Public. There we go. Now we'll do some C++. All right, string, name, right? That's not simple. Integer, or int, age, right? So on and so forth. And then if I want to write a method, right? If it's C++, we'll just create a void one with no return, right? Greeting. And then my brackets, right? And then, so I have this wonderful class. Cool.
Is it?
What's that? Is it? Not necessarily. It's cool in JavaScript. It's not cool in this language. In this language, I can create this wonderful class here. Awesome. The thing I can't do, though, is say I want to have my user give me a dynamic function. I'm going to build a dynamic function based on, like a dynamic method, based on some user input. In this language, can't do that. Not without some serious, for lack of a better term, fuckery, in order to get it to work, right? Because C++ is such a difficult language to do that type of thing in. Java, just as difficult, right? If you wanted to create a dynamic method based on user input, not crystal clear how to do that, right? It's kind of a little difficult because the problem is this isn't a thing yet, is it? It's not a thing that you can interact with. You can't actually go and dynamically add new properties and methods to it. You can't do anything with this yet until you do what? Exactly. Until you instantiate it, until you turn it into a physical object. But then the problem is now you've got this object, and you want to add some dynamic properties to this object. Cool, you can do that now because now it's an object. Now you can do whatever the heck you want with this thing, depending on the language. But the problem is you can add dynamic stuff in here, but nothing else has access to the stuff you're adding in here because it's completely self-contained. It's its own little world. You don't have any other access to it. In JavaScript, we don't have this. We have it in ES6, but at the end of the day, without getting into too much detail, it's just wrapping legacy JavaScript stuff to make it clear for people who are used to class-based languages. It's much easier for you to get it through your idea, through your head, that class does not exist, that objects are instantaneous. Objects just are there. They're immediately there, okay? So this thing, we don't need this. If I want to create a class person and have like an object person, I just create let person, create a variable, equals, whoop, 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 whoop. Object done. Ready to go. And I can start plugging properties into that immediately. I want to add name. Cool. I'll just do person dot name equals John. Automatic. Right there. Now I can do person dot name and call it, and that value will be there immediately. And I can keep doing this. And this is only one way to define objects in JavaScript. Okay? This one is called object literals. And that's the next part of this thing. Object literals allow you to create a literal object immediately using the curly syntax. That creates an object automatically. The only issue with object literals is a bit of a downside, is that they're usually used kind of like a struct, right? It's really just meant for instant data to be put into it. They're not something you would really use as a template, right? To be able to create multiple objects of the same kind of type. You don't really use them for that. For that, you use something called object constructors. But before we get way ahead of ourselves, let's talk about some of the basics of objects. Objects, like in most languages, are a way for us to encapsulate code, logic, properties, functions, tons of logic, right? Underneath a singular idea, right? Like a library, plugin, whatever you want to call them. We're encapsulating that whole thing under a singular idea. That's the whole point of object-oriented programming, right? Generally, objects tend to be best described as nouns, right? They're usually a person, place, or thing. Generally, they're a thing. Bank account, that's a thing, right? It's not an action. You can't like run bank account, right? That's not a thing. So it's a noun. They tend to be nouns. Properties are generally adjectives, whether you want to call them properties, data members, attributes, fields, whatever you want to call them. They tend to be adjectives. They're things that describe the object, right? They set state. They set properties about the object. It's hard to describe properties without using the word properties, right? But they're basically an adjective. If I have a person, a logical property would be their name. A logical property would be age or hair color, height, weight, whatever, right? Those are logical properties for it. A method, following along the lines of grammar, right? What would you say a method is usually best described as? A verb, right? It's an action. It's a thing that is occurring. It's something that's going to happen, right? It's like, I want to change your hair color. Well, you're doing something there. You're moving. You're doing something to change your hair color. If you want to change your hair color, you have to get off your butt and go to the salon and get your hair color changed, right? That's something that happens. It's an action. It's something you're going to do. And I find when you understand that about objects are nouns, properties are adjectives, and methods are verbs, you tend to create objects better. You don't wind up creating methods for things that should be a property. You don't wind up creating properties for things that should definitely be a method, right? That kind of thing. All right, cool. In JavaScript, you're going to commonly hear, and on the web when you look at YouTube videos, you're going to commonly hear, everything's an object. Everything in JavaScript is an object. That is not actually true. Not everything in JavaScript is an object. There are these things called primitives. We've used primitives quite a bit. Primitives are strings, booleans, so true or false. Numbers, undefined, which we've seen whenever we try to set something and access it and it doesn't yet have a value, and null. 5 things. 5 things in JavaScript that are not objects, right? Those things are primitives. Now, it's a bit confusing to people because they're like, well, when I type in a string like hello and I call .length, how can I do that if it's not an object? How can I call .length, which is very obviously a property of an object, how can I do that if it's not an object? And for fear of confusing you, here's what happens under the hood. JavaScript says, cool, you just type hello. Oh man, they hit a dot. Awesome. I'm going to take your hello. I'm going to pass that into an object constructor and instantiate a new string object. Here's your properties. Here's your methods. Happens instantly under the hood. You don't see any part of this process happening. You start with a primitive, but the second you hit that dot, that thing becomes an instantiated string. And now you have all these wonderful methods and properties available to you right off the bat. Same thing if you type a number, right? If you type 5. I don't know, I seem to love 5. 5 just seems to be like the go-to number. And the second you type in a dot, we're not going to have properties for this thing. Parseint. Yeah, I'm not getting anything on it. But it does get cast. It gets immediately cast to number. The second you type in 5 and hit a dot, it gets immediately cast to number, and you can start doing things with that number value. In fact, the second you go plus, it's now a number object immediately. And the result can be evaluated with other number object properties or methods. Boolean, same deal. Undefined will always just be a primitive value because there is no methods or properties on undefined. There's no methods or properties on null either. So that's important to understand. If nothing else, this is not going to be on a test. I'm never going to test you on this particular thing. It just makes you smarter JavaScript programmers, right? Makes you can be a little cocky about it. When people are like, everything's an object, you can be like, no dude, not everything. Primitives are not objects. Ha! I'm tough, I'm smart, right? That's the way it works. But yeah, that's basically the best thing you can remember. It does apply because you don't need to instantiate a string if you only need a string literal, which is a primitive. It takes up less room than the string object, right? So why would you instantiate a string if you don't need it? You don't need to instantiate a new number if you're just storing the value, right? Because the value takes up less room than a whole instantiated object does. So those are things to understand about those. Cool. Any questions about primitives? No? Nice. We're rolling like so fast. Built-in objects. We've used a bunch of these already. Like the data objects, string, number, boolean, array, object, and function. We've built, those are the built-in data objects, right? When we do this, hello, bam, we now are dealing with a string data object. We have this wonderful instantiated string data object. That's one way we can do it. If we want to create the string the old-fashioned way, we can do string, like a function call, put in Sean inside of it. That creates a string. You might remember this method that we've called before. This is the casting function, right? We've called this guy before. That casting function, it's actually an object constructor. It's actually taking your value and constructing a new object and returning it. That's what's occurring. When you call number, for example, and we pass it 5, we're constructing a new number object and returning that constructed object. That's what happens on the fly. No classes. Don't have to worry about classes. No creating interfaces. No traits. Nothing like that. No complexity. Your object is just there. You get to play with it immediately. I mean, that's the best thing about impulsive decisions, right? Just immediately get to use these things. We also have number boolean, right? We've used booleans, arrays. Here's our array syntax. Bam! Now it's an array constructor. It's immediately become an object. Cool. Turned it into an object, just like magic. David Copperfield up here. Same with Objects, right? Objects are done with these literal curly braces. Second you hit dot, it becomes an instantiated object. That's like inception. It's an object of an object. Functions. Functions are actually objects, and there's an actual function constructor, this thing right here. And I can't remember what to put in there to actually create the function, but it is a function constructor. We can actually see that. If I do new function, cool, there we go. There's my function definition that I just created on the fly. So I can create dynamic functions using that if I wanted to, which is pretty cool. These are data objects. Each can be instantiated to create new objects, but they're not to be confused with classes like in other languages. JavaScript objects exist immediately. They're instantly in existence. They are not just a blueprint. This approach allows for dynamic property and method modification creation during execution. For example, you can add new properties to the parent string. This string object that you have access to right out of the gate, you can actually go, hey, greeting equals Sean. Okay. Now I can say h equals new string. Cool. H dot greeting. Oh, it should have carried over. Oh, I did it wrong. I'm sorry. But if I do string dot greeting, it's still attached to my object constructor. We can see what properties an object has anytime we want to actually take a look at all the object properties that it has, which is, I recommend going to MDN because this doesn't actually show you everything. But it is available on the fly if you need to. This method actually works a lot better with your own personal objects than it does with the library objects. Mostly because the library objects inherit from each other. And because of that inheritance, you're not going to necessarily get the whole pathway of object properties. But it is something to be aware of. So this is the object. It's the object constructor object. And you can write that out by just calling object itself, like so. If you hit enter, you'll see that it is a function definition there. Right? That's the object constructor. You can use that and call a method on it called getOwnPropertyNames. And what that will do is it will actually take an argument. The argument is of an object type, right? You have to give it an object. When you give it the object, it will actually go through and return back all the properties that are associated with that object type. So you can put a couple of brackets. We'll type in the string object. And you can see there are 7 properties available to that object, which is not entirely true. String actually has quite a few more, like 2 lowercase, 2 uppercase. All those are properties as well. But you're only going to see the immediate. It's like what do I call it? A shallow dive into the properties. So it's not going to cascade down through all the prototypes. It's only going to give you a shallow dive to those properties. All right. So we can actually read these guys out. If you click execute, you'll see all of them are here in this wonderful object I've created here. So there's array, it has 6 shallow properties, Boolean has 3, function has 3, number has 17, object has 23, and string has 7. Why don't we take a look at how many properties the math object has. So create equals, like so, object, call the method getOwnPropertyNames. And then just pass it the actual math object. Remember, this is the thing we used last week when we were calling seal on it and stuff like that. So you just call math and click execute. And if you want to actually see what properties it has, we need to do a console log. So we'll do console.log math object properties. How many does it have? 43? Yeah, mine's got 43. Some may have more. Does anybody have more than 43? Anybody have less? See, the problem is that you only actually have to have what the ECMAScript requires you to have. But you as a browser can actually add more if you so choose. So you're going to hear this word quite a bit, ECMA, right? It shows up in like ES6, ES5. The E in those stands for ECMA. The S stands for script. What ECMA script actually means is it's a standardization. It basically says, in order for you to call yourself an ECMA 6 browser, you must implement these methods and properties. That's it. They don't care how you implement them. You can do it whatever which way you want, and they do, right? So Chrome implements them using C++. Firefox is actually using C under the hood. They do it differently. Like they implement how these things work differently, and methods in some browsers will be faster than they are in other browsers, just depending on their implementation. But for example, string.length, that is part of the ECMA standard. It's really old. It has to exist. Every browser has to have that available to it if they're going to call themselves ECMA standardized, right? So that's what ECMA basically means. So even though I have 43, if you're running a different browser, it is possible for you to have more than 43 or less, depending on which ECMA standard you're following and depending on whether or not they've added their own, because they can, or taken away ones they don't want. Cool. So we've done this with math. We're going to talk about the window object, and I'll show you something interesting with the window object. We do a console.log, and we'll just do this all in one line. Get own property names, and I'm going to pass the window object right directly in and hit execute. And it should give me the window object. Yep, there it is. In my window object, I have 883 items inside my window object. And that's because the window object is your browser API. The whole API structure is sitting inside that window object. Everything you need to access it. The navigator, which will tell you all the different principles about your browser. Basic things like parse int, the string objects, all those things are all a part of the window object. There's a lot of stuff. You can actually see a whole whack of stuff just sitting on the window object right there. Are you typing it out? That's totally fine. I was going to show you. So just one more console will run, console.log. Yeah, what browser are you using? On Windows, right? Yep. The other thing is I've defined some other functions and values inside here. And if they're at the global level, they immediately become a part of the window object. So if I define a variable inside this console, it's immediately attached as a new property to the window object. And I've defined a couple of them, so that's probably why. So window.navigator. And I would comment out the other one. Otherwise, it's very hard to get by. But there we go. Here's my navigator. Navigator tells you information about your actual Chrome, right? Or whatever browser it is you're working with. You click the down arrow, it gives you a whole bunch of different pieces of information. Tells you what thing it is. Mine's Mozilla, app name Netscape. I imagine most of you are way too young to remember Netscape. Some of you do?
Yeah.
It was awesome. I love Netscape.
I hate it.
Bluetooth, that's cool. Tells you whether or not the browser supports Bluetooth. Clipboard, connection, cookie enabled. There's a lot of information in here. And sometimes you will use this. I've used the navigator before in order to deliver a specific window size to a user based on their device, right? So I've done that, and navigator helps you to figure out which device they're actually using. So it's kind of handy. So the window object's very important. The window object is instantiated when you open your browser. It contains all the functions and variables you create at the global level, not using let or const. If you use let or const, they are not created at the window, on the window object. They're actually created at a level above that you don't have access to. It also contains all the built-in browser JavaScript API objects and methods like string to text and stuff like that. In fact, there are over 900 properties, that's a lie, over 700 properties attached to the actual window object. So quite a few. So we can actually run this following code. Number of window properties. So before we do that, if you highlight and copy the var my ludicrous var. I'm going to clear this and paste it inside your console. And then copy the function from line 13 to 15. Paste that into your console. These two things that we just did are now attached as properties to the window object. We can actually access these by just typing in window dot my ludicrous function like that, and I can see the function definition that I just defined. All right. I can also call window dot my ludicrous var, and I can see that it's storing 256. Even though we just pasted these in without attaching them as properties to the window, they immediately become a part of the window. Now, only if you've used var. If you use let or const, I'll say it again, it attaches it to a global object that's above the window that you don't have access to. So you'll never be able to see it, unfortunately. All right, cool. So if you click execute, that should say passed, and you should see your stuff in there. This also illustrates why globals are bad, because the variables defined at the root level or without a scoping modifier like let or const are immediately attached to the window object, which can obviously lead to things like symbol collisions, right? Where you're trying to access name and it's already sitting on the window object and you want to create a new name and you can't because it's already been defined, or you wind up overwriting it, which is even worse. Cool, let's talk about the document object. This is going to be just a very brief over the document object because we're going to spend 2 weeks with the document object. It's that big. It's that big of a thing. It's basically, the document object is basically your whole web page turned into an object. So it's the whole HTML page into an object. And that means all of the elements that are inside of it are all little pieces of objects, right? There's like the button object, the input object. Anything sitting inside this page has become an object that is connected to the DOM, right? The document object. And we call it the DOM, the document object model. The DOM actually contains your whole DOM API, allowing us to interact with various elements on the page. There are a lot of cool things you can do with the document object. So many, in fact, we get 2 whole classes just on document object. Actually 3 if you consider we have a 3rd class called events, which is still interacting with the DOM, but now it's with the event buffer, or with the event system. I don't want to jump ahead, but let's play with it just a little. So we're going to do something very just quick. We're going to take this button, we're going to add a color to it, and we're going to change its text property. So in here, I've already actually selected the button for you. Document is the name of the object that we're accessing, and you can type in document over here and hit enter, and you can see there's the document. And if you look at the document, you can see, oh, there's my HTML tags, there's my head tags, there's my body tag. And if you open the body tag, there's the container. This is essentially your whole HTML structure all sitting inside this document, right? So I've accessed, using the query selector method, which is a method available on document, I've accessed this thing called DOM demo 1. DOM demo 1, if I inspect the button, is the ID that is currently sitting on the button, right? So what I've done is I've used a CSS selector, right? You guys took CSS. Anybody not take CSS? Cool. It's a CSS selector, and I'm able to access that element using the CSS selector, okay? So that's awesome. So I've got my button. It's now stored inside this variable called button. And I'm using the variable scope called const, and the reason why I'm using the variable scope called const is because button is an object, and objects are passed by something called reference, which means I can't change it even if I want to. Like, I can't modify the value of it anyways, so I don't need to use let or var. I might as well just use a constant because I can't modify the value. So I've console logged out the button here as well. If you actually click execute, you'll see the button pops out like this. If you're in Chrome, it looks like this. If you're in Firefox, it doesn't. You actually get a better interactive tool with Firefox. If you want the same interactive tool in Chrome, change the console log to console dir and click execute. And then you get this, which shows you the button and the ID tag. You press the down button. These are all the methods and properties available to that button. And as you can see, there is quite a few of them. And it actually doesn't just stop there. The proto is what it's inheriting from. And that proto inherits from this proto. And that proto inherits from this proto. And that proto inherits from this proto. And yes, your button has access to all of these methods and objects that you see until it finally hits object, which is the base of everything. So tons and tons and tons of properties and methods it has access to. All right, cool. So let's do some cool things. So color, we'll take a hash color. So you know how you do like the hash colors, right? When you're doing CSS, you can give it a hash color. You just have to make sure you wrap it in the quotes. Or you can type a color directly in. As long as the browser supports that color, it will change whatever. I'm going to use Aqua because I think it actually does support Aqua. You can change your text to whatever you want. Awesome coolness. With 3 O's. That's how cool that is. Cool. So that, you're right. It should totally be coolness. Awesome coolness. All right. The R button thing. What's happening here? This is known as a event listener. What an event listener does is it literally listens. It listens for an event to occur. And the event it's listening to is on click. When the button is clicked, execute this function. That's exactly how it reads, right? So when we click the button, it will change the background color of our button to whatever color you define, and it will change your text to the text. In order to get that to work, you first have to click execute. So click execute. The binding has happened. All the things are done. So now if you click your button, bam, you should see your whatever your thing is. Cool, eh? That's just touching the surface. We're going to do lots of cool things. My favorite, my absolute favorite class, I even created a t-shirt for it. I'll show you. Just ignore that. I had an interesting class before you guys. Not that you're not interesting, you're very interesting. All right, hold on. Let's see if it works. Oh, it does. It's just outputting to the wrong thing. Here, I'll turn up my volume. You guys know how to play Simon Says, right? So Simon Says, you click the button.
What's this game over?
We have to reset it. We'll refresh. Now we'll press start. Cool. And you just keep repeating it. You seriously never played this game before?
I was kidding.
All right. I don't think you were. All right. Anyways, when we get into learning about events, we're going to build that. We'll build that as a class, and that's definitely one way to learn about events because you have to do so many. And those tones you're hearing, we're actually going to create those tones. Those aren't MP3 files. They're not WAV files. They're actually being created programmatically in order to create the tone that you hear using frequencies. Yeah, it's pretty neat, actually. All right, so let's talk about do you need a break? Who needs a break? Really? You guys are hardcore. All right.
Let's do this.
I need 2 seconds. I just need a drink, and then I'm good. Oh, okay. Let's. I mean, if you look where the little slash is,
We're almost done.
yeah, we're getting there, right? Object literals. Object literals are literally objects, right? So an object literal, you might be like, hey, Sean, how do I create an object literal? Cool, I'll show you how to create an object literal. Bam, you created an object literal. That's an object literal. It's just these curly braces. That tells the interpreter this is an object. You don't even have to assign it to anything, right? Because you can pass it as a value to whatever you want. If you want to assign it to a variable, cool, now person is equal to that object literal, right? And now you can use person as a way to reference your object literal and do whatever it is you want to do with it. Objects inside JavaScript are passed by reference. Okay? Some people have difficulty understanding what that means. There's 2 types of ways we pass values around, right? We pass values by value, right? Which literally takes a copy of your value and moves it about. So for example, say you have x equals 5 and y equals x, right? And then you go x equals 6. What is the value of y? I'll give you a hint. It's passed by value, not reference. Right, it's 5. And the reason why it's 5 is because this literally goes off, right? This goes, okay, so first of all, this goes into E0056, whatever, right? This is the memory address, and it stores 5 in here, into this memory address. When we say y equals x, what it does is it goes, creates a new memory address, 5, 7, takes this value, and copies it into there. That's basically what happens. So these always get passed by copy. Whenever we're making a variable equal to another variable, as long as the value is a literal value, like a string, it has to be a primitive. If it's a string, a boolean, a number, undefined or null, they're passed by copy. However, something really different changes when we start working with objects. Objects are a bit different. If I have person as my object, and I say let Dave equal to person, right? And then I say Dave.name, equals Dave. Okay? What will this equal? Person.name. And this is passed by reference. Dave. And the reason is because even though we're assigning person to here, this isn't assigning person. What it's doing, person points to 0xe5546. That's our memory address for person. Okay? And when we say Dave is equal to person, all we're doing is saying to Dave, hey, dude, you're now referencing this address location. So if you modify Dave, you're modifying person. That is true for two things inside. That's objects and functions. They're the only two things that are passed by object, or passed by reference. Okay? That's the difference. Reference versus value. We'll be talking about it often, and you'll experience it often, so don't worry if you're a little confused. That's totally fine. Because you're going to do it so much, you'll get very used to it. All right, so creating a new object, very simple. You don't even need this. You only need these two pieces to create a new object. Just the curly braces, that immediately creates an object. But obviously, if you create an object and don't assign it to anything, it's going to be very hard to reference it, right, to access it. So you definitely usually want to assign it to something, right? Sometimes you'll pass objects by themselves into things. That's totally fine. But most times you'll assign it. When we want to add properties, we have to use key value notation in order to do that. How many of you are familiar with JSON, out of curiosity? Yeah, so that should seem familiar. The difference between this and JSON is that JSON, you can't assign functions in JSON. You can't put function definitions inside JSON. You can't put other object references inside JSON because it's string-based only. It's just a string. That's all JSON is. However, literal objects, anything that is a value can be assigned to a key. Anything that is a value can be assigned to a key, which means you can assign strings, numbers, booleans, arrays, objects, and also functions. You can assign a function definition directly to a value, which essentially makes it a method. Okay? So that's what we're doing here. We're assigning three values to our properties. Our properties are name, age, and DOB. They are comma separated. And anytime you're working with literal objects, it's always key value. Key value, key value, key value. They can be nested, right? So you can have multiple nestings of key value, but it's always key value, key value, key value. Okay? So let's create an object. I've already given you the stub for it, right? Let person. To create the literal object, what syntax do I need? Just the curly braces, that's right. Now, you can leave that semicolon there. That is not incorrect syntax, but you don't have to have it either, right? So it's your choice. I kind of like to leave it there. Just, I don't know why. It just works for me. All right, we can go ahead and give our objects free properties. You're going to give it name, age, and DOB. Whatever you want to write as your name, you go for it. I'm going to write something different because I always write the same stuff. Humphrey Bogart. Now, when I want to add another property, I have to put a comma afterwards, not a semicolon. A semicolon is incorrect and will cause a syntax error, right? So let's see what the syntax error will be. Uncaught, syntax error, unexpected token, blah, at line 7, colon 26. Well, that's slightly off because it's actually on the line above, but whatever, we see that that's not right. So to fix that, we change it to a comma, okay? Something to note, depending on languages you've come from, JavaScript does not support trailing commas. What a trailing comma is I have put a comma here, but I have no new value underneath it. Those are called trailing commas. And if you hit execute, you will get an error saying something is undefined, whatever. This is actually wrong. You would actually get an error telling you that there's an unexpected comma and you haven't initialized anything else. So we need to put in the next piece. So that's age is the next property. And then whatever age you want to put in there, just make sure it's a number. Actually, I'm pretty sure Humphrey Bogart is much older than 40. I think he's dead. I'm going to say he's 95. I mean, you still age even when you're dead, right? All right, that's dark. DOB, date of birth. I don't know, what's 2019 minus 95? 1920, old. I agree, old. I'm going to write old. Old is a good one. All right, let's click execute, and if everything is defined properly, it should just say pass. You shouldn't get any errors. And you've written your first literal object. Yeah?
Why are we using let in this one instead of constant?
Actually, it doesn't... That's a good question because it doesn't matter, because you could do const, because const is only referring to the person part of it, and it's already a literal object. I'm pretty sure once you've done const... The only thing I was concerned about is that you wouldn't be able to add a new property to it. Let's just try my new prop equals booyah. Really? Person of type is undefined, so I'm guessing it's because it's const. Let me try if it's let. Yeah, so if you're going to add properties to it, it has to be let because you're technically mutating it. That's why.
But if we do let, can we change any property?
Yeah, let's totally mutable. Yeah, you can modify whatever you want. What's that?
Only constant we can change the property, right?
Right, because it's constant. Yeah.
Even if it's given by reference, passing value by reference.
It doesn't matter because you're still, yes, it's still passed by reference, but you can still modify it. You can do that with the other ones too. Like even button that we pulled down up here, if we wanted to create a new property on button and we didn't make it a const, we made it a let, we can literally add whatever properties we want to it. And some advanced JavaScript programmers will modify the core library. They do it all the time. Some of them have libraries they put in that make it more efficient and faster and stuff. I imagine people do that even with Java. They modify the core libraries, like Boost. You guys have heard of Boost? Boost is a really famous library that exists for a lot of different languages, and it tends to modify the core library of whatever programming language you're working with. C and C++ are notorious for using Boost because their implementation of like strings and math functions is much faster, more efficient, just works better. Better algorithms and stuff like that. So no different with JavaScript, you can do the same thing. Yeah. All right, cool. So adding methods. Now I'm going to call these methods, but I think I said before, JavaScript doesn't have methods, right? Only has properties. That's it. But a property can have a function definition as its value. So we're going to call those methods. Whenever I say method, I mean a function definition has been assigned to this thing. Okay? So, modifying the above object, create a new method called bio and have it return the following. So go ahead and copy that thing on line 8. That'll be step 1. And then step 2, we're going to add a new key value pair. So I'm going to press comma, right, because I'm about to create a new key value pair. It's called bio, right? And this is going to be an anonymous function. So do I give it a name? No, right? So we go function, set of brackets, curly braces. And all I want to do is return that thing that I copied. So I'm going to do return, and then paste that thing in place with a semicolon. What do these backticks mean? What do the backticks mean?
Something really cool.
So close. String, not catenation. Interpolation. Yeah. And these things here are where the interpolation is occurring. That's what that structure means. Does anybody know what this means? The keyword this. What's that? Do you know what the keyword this means?
No, not really.
You guys have used this in Java, right?
But I don't know.
What's that?
To choose index variable, like the lifetime index variable.
Yes. Yes. It's the context variable. It's the one that's actually referring to person. It's referring to the object we're in. It's the owner object. That's what we call that, the owner object. This is referencing the owner object, okay?
No issue.
The cool thing about that is it means we don't have to do things like this, right? We don't need to do that because we're already in there. Why would we just call person again? That seems redundant, right? We already know we're in there, so we use this because we're already inside the object, right? So it's this thing I'm currently in, that name. That's the one I want to use. This gets a bit confusing when you start getting into function bindings because context changes. When you start dealing with callbacks and you start putting callbacks in, the context changes to the callback itself, which can cause some issues and people get a bit confused with it. But this, in this scenario, is pretty simple. It just refers to person. So we modified the above object. We created a new method called bio. Step 2, now we're going to execute the value or the method. So the way we execute values or access methods, very simple. It's just person dot. The dot says to the interpreter, I am now accessing a property that is on this object. That's what I'm doing. And the one I want to access is bio, right? But if I do just this, what do I get back?
The whole function.
Right, I get the whole function back. I get the function definition back and not the function call. I won't get the return value, I'll get the definition back. I want the return value, so what do I need? Exactly, I need the brackets. And it says execute the bio function and console log the return value, so we better write console log around it. Whoop. 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 There you go. Sound effects and all. And if you click execute, click it. Should say whatever you wrote in yours.
Damn, my name is here.
Except for that, looks like it says Humphrey Bogart is eval.
Right?
It's just because of the way they do the silly thing, but
TXN, you're in the
yeah, it should. That's better. It's 95 years old or 95 eval. There we go. So adding new properties and methods to an object can be done both internally, which is where you actually modify the object structure, or externally, which you will do a lot. You will create a base object, and then based on different dynamic properties or things that you're doing, based on logic, right, like if conditions and things, you'll define new properties or new methods to it based on those particular things. That's the cool thing about JavaScript. You can actually build these objects dynamically so they're custom for that person's scenario, right? You can't do that in other languages. You can't create a dynamic class. That's not a thing. But in JavaScript, you can create dynamic objects. So if we want to add new properties to person, it's very simple. We just simply refer to person and then do a dot concatenation onto it, or sorry, a dot property, whatever we want to call the property name, and just make it equal to a value. As soon as we do that, we now have a new property with a new value in it. And you can do the same thing with a function. It's not any different. These two things are exactly the same. The only difference is the value in this one is a string, and the value in this one is a function that returns pink fluffy unicorn bunny beast. Right? Very cool. All right, let's do it. I mean, why not, right? So this thing here, don't be alarmed. This little bit of a snippet here allows me to access the person object you created above. So M4 just stands for module 4. P7 stands for the IDE that we were working with, which was the one above it. And then there's an EMV property on it. And then there's a person, which now you guys should know how to read this, right? M4P7 is an object. EMV is a property on that object. Person is another property on that object, right? Because you can nest your properties. So below will only work if you've done practice 7 and clicked execute. If you haven't clicked execute, that variable you see there doesn't exist yet. It gets created. This is a good example of dynamic object creation. It gets created on the fly when you click execute. All right, cool. So step 1, create a new property on the person below that stores their height. Okay, let's do that. So person.height equals, I don't know how tall I am. I think I'm 173 centimeters. Just put in a number, though. Don't put it in a string. I think 173 is 5'6", though. I'm 5'7", right on the nose. So I don't know.
5'7"?
Yeah.
Yeah, 172 and 73.
Yeah. Or we can find out in a second. All right. Step 2, create a new method on person below that converts their height to inches. Don't worry, I'll give you the math. You don't have to look it up. All right, so we're going to say person, and you can call your function whatever you want. I've written some crazy logic in the background that'll read your function name. I'm going to call mine height to inches equals function. Bam. And I'm going to return height times 0.39. There it is. 0.393701. I'll write that down. I'm running out of board. 0.39. Thank you. 3701. Okay. And that should return it back. If you click execute, bam. So it says height is not defined. And the reason why it says height is not defined, does anybody know why it says height is not defined? Fantastic. That makes me happy to hear. So am I going to say person.height? Fantastic. I'm going to say this.height because that's the context I'm in, right? And boom. But we haven't actually called it yet. We just added it. We haven't actually done anything with it. So why don't we call the function? We'll do a console.log. Console.log. And we'll do person.height to inches and use the brackets so that we execute the function. And now if we click execute, I get 68.11 inches, which would be 5 foot. Oh, it's almost 5'8". Yeah. So I was a bit off. I think you're right. It's like 172. I mean, do you guys even know what feet and inches are? Like, do you guys talk in feet and inches at all? Okay. Just double checking because some people don't.
I don't know centimeters.
Oh, you don't know metric then?
No.
You did metric at school, right?
Yeah, but like I'm more used to inches, feet.
Right, that's what I've always talked to. But that was my generation. It's weird because like millennial Canadians don't know inches and feet. They only know metric.
Metric,
Yeah.
Well, it really goes into like inches. It's like this right here, this space. Is it?
It's like an inch. And supposedly this distance is also too. Yeah.
Yeah.
It's like 1 inch.
So, like your foot, the one of the size is almost a foot.
Yeah, that's because that's how they measured way back in like medieval times, right? Yeah. All right, cool. So there's an issue with this whole thing, right? Like it's cool we have this object, but this object is owned by Humphrey Bogart. All of the details inside this object are Humphrey Bogart. If I want to create another person I'm really just creating another Humphrey Bogart. That's all I'm doing. That doesn't really make a lot of sense because we don't really want that. That's why classes are there, right? That's why you guys use classes, because classes are abstracted. That's what that word means, abstracted logic. It's like, I have all this logic, but it doesn't necessarily pertain to Humphrey Bogart. It is applicable to anybody. Anybody should be able to create this and add their information into it. So we abstract that logic away, and generally in class-based languages, we abstract it to a class. But in JavaScript, we don't have classes. Well, it's not entirely accurate. There's this thing in ES6 called class that you may come across, but ES6 wraps JavaScript and adds extra functionality to it, but the problem with that is it's a little slower than just using vanilla JavaScript. Anyway, so we can actually use something called an object constructor. The object constructor will allow us to basically create a template that we can call. And we already I just had an epiphany when I was saying that out loud. We already use something that abstracts logic and creates a template for us. Functions, right? That's what we use functions for. Functions abstract logic. We use parameters as placeholders so we can dynamically modify our function's return value. And that's cool because that's what we're going to use to create object constructors. We're going to create an object constructor using functions. The function will actually allow us to blueprint our object constructor, and then we can use that to create new people. And this gets a bit bizarre because I'm not sure how often you've ever done this before, or if you even can in Java. We're going to create a function inside a function. We're actually going to define the function inside of the function, okay? Which kind of like makes people go, how are you doing that? Like, how is this possible? But it's because JavaScript's cool. That's my basic reasoning. JavaScript is cool. Object constructors are simply just a standard function. That's the cool thing about it too. It's already syntax you guys have been writing. You've already written functions. Awesome. You know how to create an object constructor right out of the gate. So, but for what we want an object to look like, we use them as like blueprints, right? So remember, properties in JavaScript can contain any value type, including function definitions. In order for us to utilize object constructors, we need to understand the concept of this. But we already do. We talked about this. This is a context variable. It literally refers to the thing it's inside of, right? It refers to the object it's inside of. And as we stated before, you might be like, well, a function's not an object. But that's wrong. A function is an object. The only things that are not objects in JavaScript are the primitives, right? And is function a primitive? No, it isn't. So it makes it an object. So it literally functions, not to use the word, but functions like an object. You can add properties to it. You can do tons of cool things with it. All right, so this is a powerful keyword in object-oriented programming. In objects, this represents the owner object, which in the case of an object constructor would be the wrapping function. Not like wrapping function. This is the thing that wraps it. That was a total lame dad joke. I really apologize. All right, remember, most things in JavaScript are already objects. This includes functions. And I say this like 6 times in the Silly Lab, but remember, object constructors are simply functions. Don't get confused. They're not a confusing thing. They are simply a function. That's it. You guys are so used to using them. You've already written them before. You're just going to get to do some cool new stuff with it. So step 1, dry up our person object by converting it into an object constructor. Call the function person. Define 3 parameters. We know how to create parameters, right? Create 3 properties. That's the different part. But don't get scared. It's actually really, really easy. So first thing we're going to do, we're going to create the function. Function, right? Just like any other time. Person, but a lot of people when they're creating function constructors, the common convention is to capitalize the name. So we're going to capitalize it to person. That tells people quickly reading your code that that's an object constructor usually. Yeah. Cool, we need a parameter list. That's what these actually mean. I'm not sure if you knew that. This actually is a parameter list. And in languages like C++, a parameter list is a data type. I didn't know that, but it's kind of cool. All right, so we're going to do name, age, and DOB, because we're drying up our stuff. Dry this up. Need an opening curly brace set. And then it wants us to create 3 properties on the object. Wow. Person is already an object. That function is already an object. And if I want to create properties on it internally, all I need to do is use this to create that. So I'm going to go this dot name equal to the name that the user passes when they call the function. This dot age will be equal to age that they pass. And this dot DOB is equal to DOB. You guys have written constructors before, right? Looks just like that, doesn't it? Very similar to this structure. You guys have probably done the same kind of stuff. The same kind of redundancy where you write it over and over again. This dot name is equal to name.
I don't like it.
Yeah, I've never been a big fan of it either. And there are ways to make that cleaner and smoother, but that's just the way we do it. We can use something called destructuring that does it better.
Also this, there has to be already an object by the name of person.
No, we've already created it. The second we wrote function person, this became an object. Instantly. Instantly exists as an object. And just so you know, basically what happens when you create function person, underneath the hood, JavaScript's like, cool, you're creating a function. That's an object. So I'm going to create person, I'm going to create this object, I'm going to add in the function abilities to it, which will give you a constructor, it will give you the prototypal method, which is only exclusive to functions, gives you a whole bunch of other stuff, builds out that object, and then spits it back at you. That instantly happens when you call that syntax. Yeah.
Like in Java, can you overload the constructor?
Can you overwrite them?
Overload.
No. Yeah, JavaScript doesn't support overloading, unfortunately. Yeah. You can redeclare it. Like you can do another function again with person in it, but no, you can't unfortunately overload. Yeah. In fact, JavaScript is interesting because JavaScript programmers don't want you to program in an object-oriented way. They don't want you to think object-oriented programming. They don't want you building classes and interfaces and traits or overloading or overriding. They don't want you to do that. What they want you to do is embrace something called functional programming. Functional programming is kind of a hard thing to wrap your head around, but the idea is that functions are values, and you pass these things around and create things doing something called, it's not conceptualization, not consignment, component? I think it's called component. It's basically the way React works, right? The idea is that using functions, you build a function. Using other functions, you build a function that does what you need it to do. And because you can do that dynamically in JavaScript, you're building this customized function for a person. Kind of follows, how many of you have done design patterns, out of curiosity, like programming design patterns? If you really want to know what it's like, look up the factory design pattern, right? Gang of Four is a really good book. The factory design pattern works on that same principle. The idea of the factory design pattern is you give it the pieces and it builds the thing out just like a factory would build a car, right? You chose your paint, you chose your tires, you chose all these things, and the factory assembles this thing, and out the other end, it spits out a car. But in JavaScript, we spit out a function, this custom function for this person, and then you use that function to execute your code. That's the way JavaScript wants you to work with it. It wants you to use it as a functional programming language. If you want to know more, I think I've talked about him before. On YouTube, there's Fun Function. And he has a whole playlist on functional programming. He starts with higher order functions, and he talks about how you use functions to create these component-based functions. I would recommend watching him if you like JavaScript and you kind of think JavaScript is cool. Watch his videos and you'll become a very good JavaScript programmer, because he works for Spotify, just to give you an idea. Like, he's not just some Joe on the internet. He works for Spotify. Before Spotify, he worked for RIM, who makes BlackBerry, and he coded for them, so he knows what he's talking about. Cool, so we've created this. Now we want to actually instantiate some new people, but before we do that, let's create a function inside a function. I know it doesn't say it on there, but we might as well. I mean, let's just copy everything we did in the other one down. So this.bio equals function, anonymous function, right? We're not even going to give it a name. Though you could literally go function bio, and it would immediately be attached as a property to the object. So this dot bio equals function, and we're going to copy and paste because exactly that's the best explanation I've ever heard. Why not? Okay, I'll just go Command C, zoom, come back down here, Command B. There we go. Because the logic works.
But don't you have to put it in the parameters as well?
Don't I have to put it in the parameters?
The parameter
Bio?
that you-
No, it's a function. I don't need them to pass me their function, though I could.
But your function need a parameter as well.
Nope. It has access to the global object, right? So because this function is inside of this function, everything cascades down. So it has access to name, age, and DOB immediately as part of the owner function.
But if we needed something to be passed to that function.
Oh yeah, you totally can. You can give it parameters and then pass new information into it if you wanted to. Yeah, why don't we do that? Why not, right? Let's do quote, right? And we'll say, they like to say quote. There you go. So now when you call it, you can pass in quote, and it will be added to that string. Huh? Kind of like Leonardo DiCaprio Inception. You really want to blow your mind? Write functions with callbacks in them that do callbacks that do callbacks. And it gets really confusing after a while. I quit. All right, why don't we write one more? Because we did have the height one, right? So we'll add height. But before we do that, we should actually add that as a parameter. So we'll add it as a parameter, height, so they can pass that in. We'll do this dot height equals height. There we go. So now they can add height. And then we'll do this dot height 2 inches equals function, like so. And we're going to return this dot height times 0.39701. No, 393,701. Semicolon. There we go. That's our big object constructor. Kind of ceases to look like a function anymore, though, right? It doesn't really look like a function anymore because it's got this weird this context. But as long as you understand, functions are objects. Then why it has this, like why does it have this? Makes sense because objects are allowed to have this. Objects have the keyword this. That is something that is an object, right? Objects can have properties and methods. And I find that that's the easiest way for new JavaScript programmers to try to wrap their brain around this. Don't think of function as a function. Just think of it as an object constructor. That's all it is, right? Which means it makes it a lot easier to accept that it has access to the keyword this, that it has access to properties, that you can actually add methods into it. It makes it a lot easier to grasp that concept. Do you have a question?
Yeah. When you're instantiating this function,
We're going to instantiate it just below. I'm just waiting for people to catch up.
how do we pass the value of quote?
How are we going to pass the value of quote? When we call it, we're literally just going to wrap parentheses and put it inside of it. So it won't be fired when we instantiate. It will be fired with the thing we instantiate with. Yeah. Anybody still typing that out? No? Ready? All right, let's instantiate our first person. You can create them, call them whatever you want. I've got cool logic in the background that deciphers what you type. So I'm going to do let or const, it doesn't really matter. Give me a name. Any name. Carlos? I like that name. Carlos. There we go. Equals new, right? You guys are used to the new keyword. You've used new before. That's how we're going to instantiate this object. We're going to create a new version of it, new person. Now, interestingly enough, you can create a new person, but unlike other languages that contain constructors where you have to give those arguments, you have no choice, or it will blow up and tell you didn't do it correctly. This is JavaScript, and you don't have to give the arguments if you don't want to. You don't need to. Obviously, when you go to try to access those arguments, you're going to have a problem, but you don't have to pass them, okay? So that's something to note. But we're going to pass them, so we'll give a set of parentheses, right? And what's the first argument? Name? Because, I mean, it's up there, and I can't read it. Right? We're going to use Carlos as the name. And how old is Carlos? 20? People are just answering for Carlos. All right, cool. When's Carlos' birthday, random people? Did you say 94? 1994. What month? January 01. What day?
24.
19. You're no longer in control. We now control the vertical and the horizontal. All right. How tall is Carlos in centimeters?
Sure.
171?
No, one.
Just one. Just 1 centimeter. He's just a tiny fellow. All right. Let's do Cynthia. You okay with that, Cynthia? New person. Cynthia. I mean, what, 22? Yeah, we'll go with that. All right. 1992, I guess, then? Yep. What month? Why not? She's 22.
No, that's not correct at all.
Oh, you people. 2019 minus 22. 1997, actually. Which means Carlos, there's no way he was born in 94.
Absolutely not. No, she said
It's like 98.
Yeah, it'd be like 98 or 99, yeah. All right, what month? You've given up. You're just like, I don't care, dude. Whatever you want.
05. Okay, 06.
All right.
Shit, that's actually my birthday. 06, 23.
And how many centimeters are we?
Is it?
28? 189? That's tall. All right. I mean, how tall would that be? Like 8 foot, nearly? 7 foot and a bit? Is it 6'2"? What do you want from me? Math is not my strongest. Like, what is that, 20 feet? All right, so now if we click execute, console's clear, you should get a pass, but obviously we're not going to see anything, right? That kind of sucks. I want to see stuff. I'm going to show you something cool that you didn't know about these wonderful IDEs. Every one of these IDEs has an object associated. In the background, I create a function, right? This function exists immediately. This function for this one is called M4P, what one is that? Practice 9. It's called M4P9. When you hit execute, M4P9 immediately gets instantiated. And I add properties to this thing. It's a function, but I'm adding properties to it dynamically. I add an environment property, which allows me to store all your variables that you create. I add a object function, which is the thing that creates this wonderful window, is a library called CodeMirrors. I add the CodeMirrors object to it so I can interact with it. There's a lot of cool stuff. And this code is not obfuscated from you, by the way. You have access to all of the code that I've created to build these IDEs sitting inside GitHub. Please evaluate that code. It's worth your while. You get to see some cool stuff you can actually do with JavaScript. And I'm modifying it all the time, right? So anyways, let me show you. We can actually see Carlos and Cynthia directly using that variable. If we go M4P9, so we have M4P9, that's the object name that we're working with. Hit dot, you'll get a list of all the properties that are available to it, and you'll see one called env. So we're going to go env, right? And if you just hit enter, you'll see all the different things available on that environment. There's our person object, right, sitting on that environment. There's Carlos, and there's Cynthia. So if I click open the Carlos one, you can see he's 20. There's a bio function available to them. That's the date of birth. There's the height to inches function, and there's the name. it alphabetizes inside your browser. Some browsers won't, but most browsers do. They'll alphabetize it. Now, if I want to call Carlos, what I would do is call m4p9.env dot Carlos, exactly. And I want to call the bio, so dot bio. See how we're chaining from object to object to object. And then the set of parentheses to call the actual bio function. Hit enter, and I get Carlos is 20 years old. They were born on 1994-01-19, and they like to say undefined. Because we need to give it a quote, right? What's your favorite saying, Carlos?
Why not?
Why not? I like how people just answer for Carlos. Why not? Helps if you spell why not. There we go. Hit enter. They like to say why not. Let's check the height. Let's see what 1 centimeter equals out into inches. All right. Dot height 2 inches. 2 inches. 0.39701, obviously. Right? I mean, that's what 1 times that would be.
But we have to check to make sure.
So you're less than half an inch tall. That's pretty short. All right. We can do the same thing with Cynthia. We just change Carlos out to Cynthia. Bam. She's 74 centimeters tall, which I am curious, divided by 12 is 6 foot and a bit. 6 foot and an inch and a half. So now, I told you this stuff can be dynamic, right? You can access this stuff dynamically. Carlos is a separated person from Cynthia, but what if I want to output both of their height and I don't want to write redundant code? Well, I'll show you. We can write a for loop inside wherever. Well, why don't we write in the IDE, actually, because the IDE makes more sense. There we go. We'll write it over here. So we're going to say for, and then I can pass the 2 objects as an array, right? So I'm going to say for let peep of an array of Carlos, comma, Cynthia, like so. Cool. So I'm passing the array right directly in. I'm not storing it in a variable and then passing it in. I'm just writing the array immediately in here because that's what the for of loop does. It iterates over the array. If you don't remember that, please review week 2. Okay? So now I can access that particular property, but you might be like, how are you going to access the dot part of it? Like, how do you get that thing? Well, I can go peep, right? I can say console.log peep, and because both of them have the height property, I just call height, like that. But I'm not limited to calling it that way. Maybe I don't want to call it that way. Maybe I want to do something a bit different. Maybe I want to loop through and spit out their name, age, height, and all the rest of it. So now I'm going to write a loop inside my loop. Cool? So I'm going to say for let prop of. Now here's where the problem is. The dot syntax, right? Dot name. This thing here is a symbol. Right? And when you call it on a as a property on an object, that's fine. This symbol will translate into whatever is needed and return back the value. You can't, however, do this and pass it in as a string. You also can't take an array and put name, age, and so on inside of it, because what will happen? What will these get evaluated as? They'll be variables, and they'll be evaluated as undefined, because they haven't been defined yet, right? So the way around this, we create an array of strings. Name, age, DOB, like so. Right, so now we have name, age, and DOB. Why don't we add height in there too while we're at it? Those are our basic properties, right? Height. And then to actually spit those out, what I do is console.log. Okay, we've done that before. We reference the person, so peep. And instead of dot, we're going to use the index syntax. And inside the index syntax, I can type in prop. Because I can pass a string in there and it will return back the value the same as this dot. So, just to clarify so you understand what's happening here. Person dot name, okay, is equal to person square bracket string name. These two things are the same. They're exactly the same thing. The reason why that's neat is because you can do things like this where you can dynamically iterate through and just use the string to access the property. So when I click execute, we see Carlos, 20, the date of birth, and the height. And then we see Cynthia, 22, the date of birth, and the height. We're not done. We're going to do one more very cool thing. We have functions in here, don't we? We have very cool functions in here. We have bio, and we have to height. But I can't just pass bio and height in here, because how is this going to know it's a function? Right? Well, let's take a look. Let's do comma, bio, comma, whatever the name of that function was. Is it height to inches?
Yeah.
2 inches. Now we're going to need an if condition. Because what we're going to do with the if condition is we're going to say, hey, are you a function? Because if you're a function, I want to execute you. But if you're not, then I want to just spit out your value. So let's, next line, we'll write, there we go. We'll move this up a bit. If, need a set of parentheses. We're going to use the operator type of, which will tell us what type this thing is. Peep, prop equals function. Else, and then we'll move this one up and put it in the else. There we go. So what this is doing is it's checking peep, right? So peep will either be Carlos or Cynthia. It's checking the prop, which will be either name, age, DOB, height, bio, or height to inches. And then it's checking the type of. So it says the type of this value, is it a function? That's what it's checking. Is the type of this value a function? Because it's a lot harder for us to tell whether or not the type of the value is a string, a Boolean array, or any of those things. Those things I don't care about. If there are any of those things, I'll just console log them out. But if it's a function, I want to execute it. And the only way I can execute it is with what? Exactly, the set of parentheses. So now I just go console.log, peep, prop, set of parentheses. Notice the difference between the two. This one calls the execution. This one just spits it out. Now if you would execute, you get Carlos, 20, DOB, 1. Carlos is 20 years old. They were born on 1994. Now we're not passing the quote. We would have to do another thing in order to do that. Then we get Cynthia, 22, 189. Cynthia is 22 years old, so on and so forth, and we spit out the actual height. Cool, eh? Now that you know that, you can read my evaluation stuff, because it's that, essentially. All right, so above we created a new function called person with 3 parameters. Nope, we did it with a lot more parameters. Once again, don't forget, remember, object constructors are just functions. That's all they are. You can call this function. It's not really going to do anything because it doesn't have a return value, but you're not going to break anything if you actually call the object constructor like you would call any function. It will just execute, and if there is a return value, it will return it. To get your code, do the typical thing. Just click Get Code. You'll see this big block. Go ahead and highlight it, copy it, paste it in the right submission on your lab 4, and submit it. And collect your marks.
Can you go to the practice 9?
Yep. Timmy, you want to see the big for loop?
Yeah.
Yeah. Here, let me close this off because maybe that will make it easier for you. There. Is that a bit easier? When it's not all wrapped?
I'm getting an error.
Now what's the error you're getting? Oh, you fixed it?
It was like for spelling.
That's all right.
Second.
To the second one?
Yeah.
This one? Now don't jet quite yet. We're going to talk about the assignment. We are almost done.
But we're not done. I submitted my coach.
No, we're almost done. There's no more lab stuff. You're good.
Oh, okay.
Yeah.
Jeez.
We're going to talk about the assignment.
When she's done, can you show number 7?
Yes, I can. Are you finished?
Yeah.
Okay. Okay. Higher? No worries. I think it's just that. Which one?
Step
8?
no. Step 7. Practice 7, step 4.
Oh, you can't see the console there?
I just
It's just a console. Is it not executing properly? 1 second. So it's on line 6. Scrolling back. Yeah, it should be.
Yeah, but it says locking this
That's correct. Oh, you're missing it. Sometimes the error messages come up there. Oh, yeah, you need the comma to separate them. Is it still? Oh, now it's further down. Yeah. Yeah, careful of those commas because they're key values separated. Your pen's on That's an and. That's not a number. But it doesn't tell you what place it's on. Yeah, no, it's likely our code block we wrote in here. Quote the name or something. Get them with that. So if you took a number and did quotes and then tried to evaluate it, it would come back. Yeah, see, yeah, you're basically looking either for a number. Well, not even so much necessarily a number between quotes. You're looking for something that is not a number that you're trying to treat as a number. So likely what's happening is you're multiplying by this thing that's not actually. So you know what usually causes that? If you did height is equal to 173 cm, that'll blow it up. Because cm is not a number. I'll be right with you over there. Oh, because you need to pass height as
Oh, you'll see it.
Are you wanting it? To get out of it, you just look it up. And then just hit,
Well, that's what I said, but we tried this together. Yeah. No, yeah, it's okay.
What's your question? Yeah, so this is valid. So I think it's regular requirements. That happens. They buy projects. That's so you're not sure what you might have That's because you didn't pass both. That's fine. That's totally fine. Yeah, if you scroll down to where we actually did that, yeah, you're gonna get it. Yeah. Oh, I see what you're saying. Yeah, because you passed why not? You're good. Oh, because you're not actually. Hey, you're actually oh, it's this. Get rid of this because this refers to this object up here and not this function. Right? There you go. And now we do this. I don't know. Let me pull that up again so you can see what I wrote. Yeah, it's just quote. They like to say quote. Are you using the backticks? You must be, because I saw the rest of your expression. It might be some weirdness with Chrome. So sometimes your browser will actually cache a response, and it's like, you've already done this thing. So I'm just going to deliver the last thing you did, right? So the way to get around that is you hit Control-Shift-R, and that hard refreshes the browser, and then it forces when you hit execute to execute properly. So you can do that. Control-Shift-R. No worries. To 4? What to do? 4. Oh, this one you just literally have to hit execute. You don't actually have to do anything. As soon as you hit execute, it should execute. Assignment. All right, why don't we quickly just go over the assignment, and then anybody who still needs help can come talk to me afterwards. Don't forget the quiz, but the quiz is due. I'm going to leave it. I was going to cancel this class because the weather was so bad, but it just cleared up, and I was already in Barrie, so it was fine. So the quiz is actually due next week, the day after the class, and the lab is due next week, like at the end of the week. So you have tons of time to get that stuff done. Don't let it just stockpile, though, because you'll forget, but just so you're aware. All right, so let's talk about our first assignment. You can find it underneath assignments on the left-hand side. Is it there? Does everybody see it? Does anybody not see the assignments piece? It's not. It is there? Okay, cool. All right, so in there you'll see the PDF and you'll see the zip. The zip is your starting files. I'm going to say this right off the bat because somebody always asks me, can I do my own version of this? Do I have to use your starter files or can I do my own version? The answer is yes. Go ahead. Totally think outside the box. Do your own version. However, you must have certain features, right? You can do your own version, but it must be the same as what the rubric says inside the assignment, which means you have to have hinting, you have to have incrementing scores, and you have to be able to guess the number. Okay, so those things still have to be in there, but however you want to implement them is totally up to you. I had a student last semester do everything in React. Every single project we gave him, he did it in React, which was totally fine because it's thinking outside the box. So that's absolutely okay. So create a random number guessing game using the provided files and follow the steps. You will create the following functions. Random number, which will return a random number between 1 and 100. And you're going to be like, well, I don't know how to do that. If you search on Google, how like random number in range JavaScript, it will point to MDN, and MDN has a whole description on how to do it. Or you can look up math.random on MDN and see that same example. And it tells you exactly how to do an integer return with a range. Okay? And you can literally copy and paste that. I won't give you trouble for it because that's what I did in mine. So, just make sure you call it random number. Evaluate guess. Returns a Boolean value based on a comparison between a guessed and the actual value of the random number. So you guys have guessed a number, right? Somebody's like, guess a number between 1 and 10, right? And you have to like guess whatever the number is. That's what you're building. So the computer is going to create a random number, and then your user is going to guess that random number. I'm going to show you an example in a second here. Reset board. Resets the board back to its starting state, but maintains the score. So it doesn't change the score, it just resets the board. Hint provides hints helping the user find the range they need to guess in. And process guess ties in all the above functions. This is executed when the guess button is clicked. The click event is provided for you. All you need to do is create the function. I've already created the click event and bound it. Okay? You just have to make sure your process guess is called process guess or it won't work. Unless you are creating your own from scratch, use these function names. Don't change them, okay? Because it makes it a lot harder to trace back. How do we debug our code? We use debugger and we use the console window, right? Don't hand me in broken code, okay? That's very, very important. Do not hand me in broken code because broken code means I have to spend 20 minutes figuring out why your code is broken, and I just get more and more upset the more and more I go through if there's just stupid error after stupid error, and I get really annoyed. So make sure you've opened up your debugger and your console window. In the past, I have done this before. In the past, if I open up my console window and it's something as silly as like a tiny syntax error, I zero out the page and I move on to the next one. And I tell you to resubmit. Okay? So make sure you open your console window and debug your code. I'm not expecting everybody's application to run, because that doesn't always happen, and that's fine. I'm totally okay with that. But if it's silly mistakes that I'm just correcting to get your stuff to run, that just annoys me. Okay? So make sure you debug your code. All right. Yes, you may create your own number guessing game. That's written on here. The functionality has to be the same, and yes, you may work in groups of 2. So you can choose a partner and build it together. That's totally fine. If you work in a group of 2, I do expect you to do a little bit more and add a little bit more to it. Not necessarily functionality, but definitely in like style and color and stuff like that, please. Okay, so put some effort into it. Only 1 submission per group. So obviously your partner needs to be able to get their marks. So how are you going to make sure they get their marks? You're going to create a README file with both of your names in it, right? So that I know who your partner was. You do not have to work in groups. This thing is easy enough that you shouldn't have to do that anyways, but you can. All right. That's it for that. So because this is a very common assignment, and you guys are all trustworthy people, I'm sure we're going to be okay. But because this is a very common assignment, your code will be run against Google, which means I take little blocks and snippets, and I always know. I always know, because it just stands out like a sore thumb. It's like broke, weird logic that works. Broke. So I just take the weird logic that works, throw it into Google. Oh, cool, Stack Overflow. Oh, you copied from this one. It happens every time, and it's just annoying. And if I catch cheating, I just zero out the whole thing, and I move on. I don't report you, which is a good thing. Some people like that I don't report you, but you get 0, and you'll fail my class, guaranteed. I had 8 people fail last semester, so don't cheat. Rule number 1. It's embarrassing for everybody involved, mostly you. And this is all that stuff in the PDF, but I don't do the rubric thing because the rubric in Blackboard is broken. I don't like it. So I put the rubric in the PDF. So the random number function is worth 10% of the mark, which is cool for a copy and paste because it's literally a copy and paste. Evaluate guess is worth 5 marks because you're just returning back a Boolean. Reset board is 10 marks. Hint is 10 marks. Take it further. The take it further is there's a section inside there that is wrapped that says take it further, and you can go through those steps. You don't have to, but you'll lose 10%. So the max you would be able to get would be 90%, right? But I do recommend attempting to take it further. It is more challenging. That's the purpose of it, right? It kind of shows that you're fully grasping this. So definitely do the take it further. And then the process guess, which is worth 15. These functions I'm going to execute individually. I'm going to call them and see if they work. Call them, see if it works. Call it, see if it works. Okay? Down here is the game design and function, and you'll notice it's only worth 40% of the mark. So each one of these will be marked individually, and then I'll be marking this part here. There's a tiny 10% for CSS, right? So that's the design part of it. Yeah, it's only worth 10%, but try it, okay? The game design is basically this. So I will show you how this thing works. Here's what it looks like. It's not very pretty. You're going to make it pretty, all right? I'll refresh and start fresh. All right, JavaScript number guessing game. Super awesome guess a number game. Between 1 and 100. You can actually change that value, right? You can make it 1 to 1,000,000 if you want to. It's totally up to you. All right, guess the number. Cool. Somebody give me a number.
6.
6? All right, so we'll click 6. 6 is lower than the secret number. You're within 40 of the secret number. So the take it further part is the second sentence that actually figures out the difference and then returns back using a loop within 10, right? Within 10, 20, 30, 40, 50, that kind of thing. So you're within 40, so you know that you're lower. So it must be between 6 and what number?
40.
Exactly. So what do you want me to try?
40.
40? Guess. But you're within 5.
45.
43.
Well, I'm going to try 45 first. It's higher.
43.
And you said 43. It's higher. 42.
41. No, 38.
Oh, it was 42. That's the meaning of life, right? Any of you Douglas Adams fans out there? No?
So wait, does it change every time you finish the game?
So as soon as you win, right, or lose or whatever, right? As soon as you win, your score will be incremented by whatever guesses you have left, and it will generate a new number, and then you can start all over again. Now you can technically. So if I do 2, notice what's happening to the score.
Going down. Yeah.
It's going down. It's going into negatives, right?
That's not good.
Yeah, this one's kind of broken. You can fix that if you so choose. But that's basic functionality. It's not really a huge amount of work. It's actually about 100 lines of code. It's not a lot of lines of code. It's pretty easy. Now, I've done something kind of neat for you guys as well. I have built a tester inside this code that will make it a little easier for you. Hold on, let me just open it up. All right, so here's the student version that you're going to open up, and you'll notice, see this thing that says Sean code here? Right off the bat, you have an uncaught reference error. So solve that reference error. Then start reading through the things. You haven't written your process guess function yet. Your button will not work till you do. I've written little pieces of information in here to hint and help you along, okay? Failing that, how do you contact me?
Slap.
Good man. Slack. That is your number one spot. My emails do not come to my laptop all the time, and at work, I don't get my emails at all from school, from Georgia, right? So I won't know that you've been contacting me sometimes for days if you do it by email. But if you contact me via Slack, I will respond almost immediately, like very quickly, because I get your Slack messages at work, I get your Slack messages to my phone, so I'm guaranteed to get a hold of you, and you're guaranteed to get a hold of me. You may be like, I've had students in the past say, I don't want Slack, because I'm never going to use it. I only want to use Discord, blah, blah, blah. And that's fine, but I'm going to tell you right now, Slack is one of the biggest industry standard communication tools out there. I would get used to it because you're going to use it. It's inevitable. What's that?
Why are you making me create a Slack account?
Because you're going to use it anyways. Just create one. Suck it up, Muffin. All right. So that's it. That's all I've got for you. Yeah. Call it early, I guess. 9:17. That's a good time to leave. Feel free to work on your quiz. I won't leave till 9:45. So.